Okay, so now we've got a lot more complications in here. They've given us a mass, they've given us mu, and they've given us the average setup beyond that. So what they want us to do is the same thing. We're still supposed to be trying to figure out the acceleration and the time, but we're going to have to do a little more work to get there. So the problem with mu all of a sudden is that, oh, well, that means we have friction. And so we're going to have a lot more complicated free body diagram. So in the free body diagram,
Lorna, there's a call of line 1 for you.
we
Lorna,
have
call of
the
line
force
1.
of gravity going straight down on a 10 kilogram object. So the force of gravity is just equal to mass times g. And in this case, they tell us g is 10. So my mass is, that's 10 times 10. So my force of gravity is going to be 100 newtons. So I've got 100 newtons here, working down the side. And the rest of my triangle I can set up. I've got my, actually let's try using a different color there. I've got my normal force, which is at a right angle to the surface, always. So my normal force is going to be this side of this triangle. And I remember that I've got 40 degrees here, so I can put that 40 degrees in there. Normal force is going to be the adjacent side. So if I want to find out my normal force, then I'm going to have to use the triangle that uses adjacent and hypotenuse, because gravity is always hypotenuse. If I have adjacent and hypotenuse, that's cosine. And I'm looking for my adjacent, so that means I'm going to go cosine times hypotenuse. Cos of 40 degrees times 100 is going to give me, use my little calculator here, cos 40, close bracket, times 100 equals 76.6. So we're just going to go ahead and round it because we're not dealing with a lot of significant digits here. So I've got 77 newtons on this side of the triangle. Now I still need to know, like I did before, what my active force is, which is the one that's pulling down this way, and that's my opposite side, so I'll call that my active force. And my active force is my opposite side, so I'm going to use opposite over hypotenuse, that's sine. So, and I'm solving for the opposite side, so I'm going to go sine of 40 times 100 and find out what that is. So, use my calculator, sine 40, close bracket, times 100, says it's 64. So, that one is 64 newtons, and I can just put that right here. Now, why did I bother to solve all of them? Why didn't I just do the FA? Well, because I've got another force. Let's see if this pen works. Nope. I've got another force going up this way, and that's the force of friction. And the force of friction is equal to mu times the normal force. I have mu, it's 0.25. I have the normal force, it's 77. So I use my calculator, 0.25 times 77 gives me 19.25. Yeah, why not? All right, so my friction force, we'll go with 19.3, just round it off a little bit. Newtons, okay. So, why is that a problem? Well, why is it a complication? Because you've got two forces acting against each other. That's going to change your setup. So, in order to find my acceleration, then I need my F net. So my F net is going to be the difference between these two. So my FA, my active force, is the big one, so I'm going to go 64 minus force of friction is 19.3. So my F net is going to be 44.7 newtons. So I have a total of 44.7 newtons pulling in that direction, which is going to contribute to the acceleration. I have to divide that by the mass. So acceleration is equal to F net divided by the mass. So I'm going to go 44.7 divided by 10. I've got my 10 kilograms there, which is going to give me an acceleration of 4.47 meters per second squared. So my time is going to be that nice little formula that they gave us. So I've got my two times my distance over my acceleration. And that should get us three, if we do it right. So I'll just run the numbers and check. It's interesting. Second function, square root, bracket 2 times 20, close bracket, divided by, 4.47. Yeah, 2.2 or 2.99, which is rounded up to 3. So our time is 3 seconds. This is a really good one because it has a whole bunch of different elements in it. You're going to see some questions that elaborate on this. Each step, or each question is like a little step harder, but this is the basics. You've got to have all of your forces represented and understand that you need the normal force to get your force of friction. You need your force of friction to figure out your net force. You need your net force to figure out your acceleration, and so on.